this function. Limit as x approaches 0 from x to the fourth times cosine 2 over x. This is a typical situation in which nothing else works. Factoring doesn't work, rationalizing doesn't work, simplification doesn't work. Nothing works but the squeeze theorem. First of all, we have to see what this is, right? So what is the limit of x to the fourth? The limit of x to the fourth will be 0. What is the limit from cosine of an undefined situation? No answer. So nothing works. Okay, let's think about the squeeze theorem. When nothing works, we have to think of the squeeze theorem. Okay, remember what I need to do, what I need to show. If the squeeze theorem is applicable, I have to show two things. I have to show you that this function is squeezed between two functions, but I have to find them. I have to find this function, I have to find this function and say it's squeezed between the two. Then, once I have determined those functions, what do I have to show you? That the limit from this function as x approaches 0 is 15, and the limit from this function as x approaches 0 is 15, and only then I can conclude what? That the limit of this is 15, as an example. Good. So, I know not much about x to the fourth, other than the graph around 0. But I do know something about cosine. Cosine of anything. What do I know about cosine? Meaning, I'm really talking about what is the upper bound, and what is the lower bound. What cosine is, what is the maximum possible value of cosine? 1. What is the minimum possible value of cosine? So we call this function bounded. It can never go above 1. It can never go below 1. Okay, let's make use of this. Oh, I didn't mean that. I meant 1, of course. Good. So for now, I have a starting point in which I presented a piece of the function. So I kind of have an idea about this piece. But that's not enough, because that's not the original function. What do you think I am going to do now to all three sides so that in the middle I have the function that I need to determine the limit from? What should I do to all three sides of this inequality? So that in the middle I have the function that I need, the one that I have to determine the limit from. What would you do? Say it again. No. Remember, I want to determine this. This is what I want to have right here in the middle. What do I need to do? Multiply everything by x to the fourth so I can create that particular function in the very middle, because I'm trying to show that it's squeezed between two functions. So the left-hand side is negative x to the fourth. The middle is x to the fourth cosine 2 over x, and the right-hand side is x to the fourth. And you should say, wait a minute. It's not that clear. You're multiplying by a quantity that contains x. You have to show us that it's never 0 and it's always positive. Because if this can be negative, then I may have to switch the symbols. So is this 0? Because I'm not allowed to multiply by 0. Is this 0? No. How do I know? X approaches 0. We know it's not 0. We really mean it. X approaches 0. So this is not 0. I'm safe on that one. But is it always positive?
Because if it's not always positive, I cannot multiply.
It's an even power. It'll always be positive.
Exactly. So I have to make that clear. X is not 0. That's one condition. And number 2, x to the 4th is always positive. Otherwise, I can't multiply. So this is the first step, the first hypothesis of the squeeze theorem. This in the middle is our function called h of x. What is this? Yes, it doesn't matter. The names, you're right. You can call them the way you like. It doesn't matter. What is this? That's it. So by this simple algebraic manipulation, I showed that the function we need to determine the limit from, for which we have no other method whatsoever, is indeed squeezed between two functions, around 0. Is squeezed below by negative x to the 4th, and is squeezed above by x to the 4th. But now I have the second step to show. What is the second step? What do I have to show?
You have to show that the limits of each side of the sandwich are the same.
Yes. So what is the limit from the first?
0,
What is the limit from the second?
0, 0.
What do I conclude from 1 and 2 by the squeeze theorem? What do I conclude? Yes, I conclude the limit of x to the 4th times cosine 2 over x as x approaches 0 is definitely, that's it. We determined two functions, one from above and one from below. And since both limits exist from those functions and they're 0, we conclude that the limit of the middle function must be 0. Any questions? And this is number 11. We're trying to go through all these so you know what to expect. Okay, and now I would like to work on that problem. 37 on page 107. We are told that 4x minus 9 is less than or equal to f of x, which is less than or equal to x squared minus 4x plus 7. For all x positive, we're asked to find the limit of f of x as x approaches 4. As you notice, I don't even have the function. I can't simplify, I can't rationalize, I can't factor, I can't do anything. My only hope is that I can use the squeeze or sandwich theorem. Yep. Luckily for us, we already have the first condition fulfilled. We are given the first condition. What is this? Now, since they denoted this by f of x, let's denote this by g and this by h. So they're already giving us the first hypothesis. It's already fulfilled. They're giving us the bound from below, and they're giving us the bound from above. What is the second step that we need to perform? Calculate. Yes. So limit of 4x minus 9 as x approaches. Very good, of course. And limit of x squared minus 4x plus 7 as x approaches 4. What if 1 does not exist? What do I conclude? The squeeze theorem is or is not applicable? Is not. What if I get 5 for the first one and 3 for the second one? What do I conclude? Again, it's not applicable. So let's see. What do I get for the first one? 1 more time.
16 limits are 7.
Good. That's okay. And the second one?
7.
From 1 and 2 by the squeezing theorem. And this is what I need to see on your test, exams, work. From 1 and 2, which are the hypotheses of squeeze theorem. By squeeze theorem, we conclude that the limit of f of x as x approaches from 4 from either side must be 7. Any questions? Any questions? I'm looking for a graph. If it's not here, I'll create it for you. But I would like, I like the pictures in this. It should be in here. If not, I will create it in a minute. There is a function that is called the greatest integer function. And I'm just looking to see if they present it here as a graph. It should be in chapter 1, which is a prerequisite, and if not, we'll create it ourselves. They have the absolute value in there in case you need to review anything about the absolute value. No, it's they don't present it in that. Ah, it is on page 105. I like their graph. So this function is called the greatest integer function. Obviously, is what type of function? Piecewise, right? It's a piecewise defined function. So for x between -2 and -1, the value is -2. For x between -1 and 0, it's -1. Between 0 and 1, the value is 0, and so on and so forth. Let's write it. It's because I chose, where is it? I just saw it a second ago. It's in my, I have it as an example. Where is it? Here it is. Okay, the greatest integer function. So let's write it. It's very interesting. The notation is very interesting. So it's 2 brackets with 2 bars parallel to the bracket, not at the edge, and x in the middle. So the greatest integer function. Greatest integer function. And it's a piecewise defined function, but it has infinitely many branches. Dot, 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 dot. And we are going to write, oops, sorry. We're going to write a few. So the function is -2 if x is between -2 and -1, closed at -2. The function is -1 if -1 less than or equal to x less than 0. The function is 0 for any value between 0 and 1. And I'm going to write one more. 1 for any function value between 1 and 2. And this means that it can go forever. And here's the graph of the greatest integer function. It's also called a step function. Some people call it a step function. Can anyone give us an example of a step function? Please.
I know in the book there's an example where patients given dosages of a drug at a certain hour and the drug decays.
But if it decays, it means it diminishes. This one is a step function. The text code, I don't know if they changed it. Can ask, but up until last year, for someone who makes between, I'm just making numbers up, I don't know exactly, between 0 and 50,000 pays 20% taxes. Between 50,000 and 100, 25. Between 100,000 and 150,000, 30. That's a step function. For this x, this step. For this x, this step. For these values of x, this step. Here's another example. I know everyone now is on unlimited plans and phones and so on and so forth, but in the past we had some plans. I know it's been a long time, but between 0 and 1,000 minutes, you pay $25. Between 1,000 minutes and 2,000 minutes, you pay $30. So that's another example of a step function. Okay, so now let's graph it. So for x between -2 and -1, full point, open point. This function is defined everywhere. I just wanted to show you the graph, and it's you can say, wait a minute, you just told me all the time that when I graph a function, I need to present a domain, I need to show a chart. Yes, but this is just the basic step function. So for -1, full point and open at 0. And then full point at 0 and open at 1. Full point at 1 and open at 2. And you put 3 dots, exactly 3 going up and exactly 3 going down. And now we can answer the limit on the greatest integer function. As x approaches 2 from either side, I have to find both limits. So that question on the list of limits, no, that's 10. Okay, limit of the greatest integer function when x approaches 2 from either side. You already know the answer, but we have to find both. What is the answer before we find both, left and right? Of course. So limit as x approaches 2 from the left, from the greatest integer function, what would you say? 2 from the left. Oh, I didn't show it. Let me show one more. 2 from the left. Yes. So here is 1, 2, 3. 2 from the left. 2 from the left is 1. And limit as x approaches 2 from the right. What will you say? 2 from the right. Right here. So 2 from the right.
Yeah, 2. Okay, so
2. You said 2 and I was looking at. So this is 1 and this is 2. Therefore, the limit from either side is, does not exist. Any questions? Any questions? Any questions for me? I think we got the picture with these limits. We will continue with the rest throughout the next week or so. Okay? So we can finalize that handouts. Of course, the first test is not going to be next week, so don't worry about it. We have to finish chapter 2 first. Okay? Moving on to 2.4. the precise definition of the limit. And you could say, what are you talking about? What is this? What are you saying? So here's what I want to say. Let's suppose I have a function, and it's this function. And I'm going to choose x to be 4. And I'm going to say this is 5. And I'm going to ask you, what is the limit of f of x as x approaches 4 from either side? Of course. At first, this will sound complicated. It will sound a little bit sophisticated, if you want. It's not at all. Okay, so here's my question to you. Assuming I zoom in, bless you, assuming I zoom in here, and I look at what happens around this point. Do you understand? Do you agree with me that as much as I zoom in, nothing will change, right? So I zoom in and I look closer and closer to that point, at that point, but the limit will still be 5, right? Okay, what about this situation? Assuming now, on this example, I zoom out. I'm so far away that these become so close, so close to each other. And I'm going to ask you, this is what you see right now. And I'm going to say, please give me the limit. I'm so far out. I'm a mile away. So now please tell me, what is the limit? This is what you see. What is the limit of f of x as x approaches 4 from either side? 5, right? Would you say that? Because I'm so far away I can't see. Now I want to come back, and I'm looking at this closer and closer, closer and closer. What will you say when you get closer and closer? It doesn't exist. But if I'm far away, I'll say, oh, the limit is 5. But here, no matter how close and how much I zoom in, that will never change. I will always see that the limit as x approaches 4 from either side is 5. So obviously the limit here exists in this situation, and the limit here does not exist. Keep in mind what I just said about zooming in, because that's very important. That's my next step. Okay. So why does the limit exist? Why? It's because no matter how small of an interval I choose around 5, very tiny, no matter how close that interval, how small that interval is, I will always be able to find a corresponding interval. I will repeat this several times. You don't have to write anything right now. I will always find the corresponding interval around 4, only because the limit exists. No matter how close this is or how big it is, I will always be able to find an interval corresponding around 4, such that if I pick x here, and there are some conditions that I skipped for the second just to explain the mechanism. If I pick here an x very close to 4 in the interval, where will f of x be? For sure. Where will it fall? Within the tiny interval around 5. One more time. Why? Why I can do that? Because the limit exists. Here's what happens here. For example, I'll choose this interval. I'm so far up, right? I'll choose this interval, and I'll say, if for this interval, I will be able to find an interval around 4 such that if I pick x here, where will f of x be? Where will it fall? Correct. But the difference between these two is the word for, or the words are the words for any. This one says for any interval you want, as small as you wanted it to be, you will find the interval around 4, such that if you pick x here, it will fall within tiny distance from 5. But this one does not work for any. If I choose now this interval, I can't. Here's what happens. I can no longer show you the interval around 4. I can no longer say here, I pick x and it will fall within the interval, because I can't. So the difference between these two is the word for any interval around 5. I can do that. But here, I can show you for some, but not for all, and not for any. So, this is the mechanism. So now let me show you an example, and then we will write the whole theorem. Okay, so let's start with a very simple example, a numerical example, and then we'll write the theorem, and then we'll determine full blast. Okay, so here are the numerical examples. 1, 2, 3, 4. Good examples. And here are the non-numerical examples. We can't jump into these just yet. Let's look at a numerical example first. Okay, so let's say we pick, let's say number 2 on page 116. And use the given graph of f to find the number delta. I'll explain what delta means, such that